Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Yin Yin Yang by Hunsar. And here are the rules. We have normal Sudoku rules apply, which means in every cell, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, in this case a box. We also have yin yang, where we shade some cells such that all shaded and unshaded cells each form an orthogonally connected region. Additionally, no 2x2 regions may be entirely shaded or entirely unshaded. So, as an example, we could have something along the lines of this, something like this, where basically the shaded regions are all orthogonally connected with each other. And by that, it means we can go from any cell in the shaded region to any other cell in the shaded region and stay within that shaded region just by going through edges. So for example, you could go to here just by going along this path and just going through edges. What is not valid is something along the lines of like this, right? Because this, well, for the unshaded regions, these cells could not connect to the other unshaded cells just by going through edges and staying within the region, right? It has to go through here, or go through a corner to basically be able to connect to the rest of the region that way. And that's what it means to be orthogonally connected. Additionally, so this would not work because this 2x2 area would be entirely unshaded, which is not allowed. We have to have in every 2x2 cell or square on the grid, you have to have at least one unshaded cell and at least one shaded cell. So this is not allowed here. We also have double the yin. For the purposes of other rules, all shaded cells have a value of twice the digit in their cell. So for example, if this were, say, a 5, the value of the cell would actually be 10 because it's shaded. If this were a 6, the value here would be 6 because it's unshaded, right? And that's for the value of the other rules. Actually, this is to form a valid yin-yang shading, this would be that would have to be shaded. For killer cages, digits in cages may not repeat, and cell values must sum to the number in the top left corner. So for these 4 digits, the cell value must sum to 16. For these 2 digits, the cell values must sum to 10. For these 2, the cell values must sum to 25, etc., etc. And for Kropke dots, values across white Kropke dots must differ by 1. So if this had a value of, say, 9, this would have to have a value of 8 or 10, and this would then be 5 doubled if that were the case. So that's an example of how white Kropke dots work. And for values across black Kropke dots must be in a 1:2 ratio. So if this had a value of 8, well, that would be problematic. Well, yeah, if this had a value of 8, this would have to have a value of 4 or 16, but 16 would only be the value of 8 doubled. So it couldn't be 8, so it couldn't be 16 here. It would actually have to be 4 as a normal value or 2 doubled to add up to 8, or to be in a 1:2 ratio with 8. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this is going to be tricky, I think. Well, first of all, this has a value of 41. This has a value of 3, so these are unshaded. there has to be one shaded here, at least, and there probably is two. It cannot be three shaded, because then the problem is that if it's three shaded, all of them would have to have double value. So therefore, it's only two shaded. This must be shaded, and either this is shaded or this is unshaded. We're not sure which. Okay. Right. So for 25, it's the same case. One of these is shaded and one of these is unshaded, because if you would have both of them shaded, it would have to add up to an even digit, because both of their values would be doubled. So it would be 2 times something. They would both be even, and an even plus an even would equal an even. This is 25. This is at least one shaded, but we're not sure which. Okay, so because of that, we know, so for yin-yang shading, how do you call it? It's not a shortcut. Something that, basically it's a knowledge thing that you have, right? If you ever swap on a yin-yang, there's two rules, essentially, or not rules, but essentially two logical deductions that you can come up with, where basically if you ever swap to a different color, you can only swap twice, right? Along the edge of the grid. And the reasoning is, if you swap, say you swapped here, right? If you swap here and this was green, and so this was blue. If we tried swap, so this has to swap also, because one of these is blue and the other, at least one other, is green. So say we swapped here, right? This would have to be continuously blue then. So if we, assuming we swapped here, this would have to all be blue. And the reasoning is, if we tried to force a green somewhere here, even just one cell, the problem is this green must connect orthogonally to the rest of the other green cells, right? That would break this blue region into two separate regions. If you tried to basically connect the blue regions, that would force the green regions to be into two separate areas, and that's not allowed. So that's the reasoning why once you switch, it's basically the same region type. So this must be the same region type as this digit. This must be the same region type as this digit. So we're going to mark these as red and orange. But we're not sure which one's which, because the swap occurs here and here, right? We know one of these swaps, it swaps either here or swaps here. This swaps either here or here, and we're not sure which either. So this must be the orange type. This must be the red type. This must be red because of the 2x2 areas, and this must be orange. Okay. So this is all red. This is all orange. This 2x2 area has to have a double, at least one doubled value and at least one non-doubled value. How does that work, actually? I don't think you can have 3 doubled values, right? If you have 3 doubled values, you still have to have a 1-to-2 ratio between them. And therefore, it'd be 2, 4, and 8. Well, 2 would only be in a 1-to-2 ratio with 4 twice. So that doesn't work. I think this has to be 2 and 2 here, because you can have each of these cells is in a 1-to-2 ratio with 2 other cells. If you try to only double 1 or double 3, you could double 1 to go to 2 and then 2 and 2 would be in a 1 to 2 ratio with 4, but then 8 would only be in a 1 to 2 ratio with 2 other digits, right? Obviously, if you double 8, going to 8 to 16 doesn't work. If you double 2, you have values of 1, 4, 4, and 8, and 1 is not in a 1 to 2 ratio with 4, 4. So you can't have all of them doubled. It wouldn't work anyways. So it must be 2 and 2 here. Where you have 1 doubled to 2 in value, 2 doubled to 4 in value. So 2 is in a 1 to 2 ratio with both 4s. 8 is in a 1 to 2 ratio with both 4s. And the 4s are in 1 to 2 ratio with 2 and 8. So this must specifically be 1, 2, 4, and 8 here. This has to be a 1, 2 pair, and they're not doubled because that's the minimum value possible. That eliminates 1, 2, and the rest of the row. Therefore, this is a 4, 8 pair, which eliminates 4 and 8 in the rest of this box, which eliminates, so this must be a 1, 2 pair. The 1, 2 pair, again, like we said, was doubled, so these are blue. These must not be doubled, so these are green. There, and this green means the red has to not be green, right? Because then this would be a 2 by 2 area of just greens. So the reds have to be blues, and the oranges have to be greens. So this is shading here. These values are doubled, and this is not. And the reason why we knew this was not doubled, or this had to be blue, is because if you try to have 9 doubled, what's the maximum that could be? 9 doubled would be 18 plus 8 and 7, which would only add up to 18 plus 15, which is 33. So to get to 41, we need at least 2 doubled. So that's why we knew that was blue. And it had to swap to one of these. And we know now it's this way. This green has to connect to the rest of the green, so this is green here. These are doubled in value. These are not. So these two must add up to 8. Only one of these is doubled. We're not sure which. This is doubled. This is not doubled. We don't know about this one. This doubled in value is consecutive with another digit. So this must be an odd digit. It has to be, cannot be 1. This can't be 2 doubled or 1 doubled. So this can't be 3. So this is 5, 7, 9. That means this is value-wise 4, 6, 8, or 10. It cannot be 4 or 8. So it's 6 or 10. So this is either 3 or 5. So it's either 6 in value, 3 doubled with 5, or it's 5 doubled with 9. So this cannot be 7. So 5 has to be one of these two digits here. These two are doubled, and it adds with another digit, and this digit must be odd. So this is 3, 5, 7, 9. If this were 9, what's the maximum this could be? 7 and 8 doubled, which is 15 times 2, 30, 39, which is not allowed, so this can't be 9. What about if this is 3? If this is 3, these two digits values must add up to 41 minus 3, which is 38. And that's not possible. Because that would be 3 plus, yeah, you can't have 38 divided by 2 is 19. You can't have two unique digits ever add up to 19. It's 17 at most. So the 5 doesn't work either. Therefore, this is 7 and 8 and 9, right? 8 and 9 doubled is 17 times 2, which is 34, plus 7 is 41. So this is 7, 8, 9. The rest of this box must be 3 through 6. Either both of these are doubled or neither of these are doubled. We're not sure which. Either way, it cannot be 5 here. If this is 5, even if it's doubled, what can it be a 1 to 2 ratio with that's not 5? Because, again, it sees that 5 there if this is 5. So this would be, this could be 2 or 8, or this is 3 or 6 here, along with that. This can't be 5, because we know 5 has to be one of these two digits. So where is 5 in box 2? It must be here, so 5 has to be one of these 3 here. In this 2x2 area, you have at least one doubled and one non-doubled, but we don't know which is which. One of these digits must be doubled, because the blue has to go out somehow. And that means, so one of these is doubled, one of these has to be non-doubled, because if you're both doubled, it would be add up to an even digit. So you could have 3 doubled with 7. That's 6 and 7. So 3 doubled with 7. 4 doubled would have to be with 5, but then we don't have a 5 here. So this cannot be 4 and 5. It can't be 5 doubled with 3, because we have the same problem. 6 doubled would have to be with 1, but the 1-2 pair eliminates 1 from there. So this must be a 3-7 pair, which eliminates 3 and 7 in the rest of the row and the rest of the box. So this has to be 5 and 9. This 4, 5, 6 triplet eliminates 4, 5, and 6 in the rest of the box. So this is 3. This can no longer be 3 here. This can't be 6, because 6 would have to be with 3, either both doubled or neither doubled. Therefore, this must be 4 with 2 or 8. So it can't be 4. This can't be 4, and we can remove the outside part. The remaining digits in row 3 are 8 and 9. This can't be 9 because of the 9 in the column. So this is 8, this is 9. The remaining digits in row 2 are 6 and 7. And 7 cannot be here because of this 3-7 pair in the box. So this is 6, this is 7. That leaves this as 3, 4, 3, 5, and 6. This has to be 1, 2, and 4. These two digits are not doubled. They cannot be, they add up to 10. Cannot be 1, 9, 2, 8. It's 3, 7, or 4, 6 here. We're not sure which. This adds up to 16, but both are doubled. So the digits themselves add up to 8. Cannot be 1, 7. It's either 2, 6, or 3, 5 here. Okay. These are both doubled. This is doubled. One of these is doubled. So what are the possibilities here to add up to 25 for one doubled? I think it's only, it has to be an odd digit, so that's the non-doubled, and then the other digit could be anything else. So okay, if you have 9 here as the non-doubled, 25 minus 9 is 16. So this has to be 8 and 9. I think this is guaranteed to be 8 and 9 then. If we try to have 7 as the non-doubled, 25, oh, you could have 7. 7 as the non-doubled, 25 minus 7 is 18, and that's 9 doubled. So this has to have a 9. We know that for certain. 7, 8, or 9. And we guarantee that the 9 is here. So 9 cannot be here. 9 cannot be here. 9 has to then be in one of, for box 6, it has to be one of these cells. Since 9 is here, we have to have at least 3 non-doubles and at least 1 double. Sorry, we have to have at least one non-double and one double. But if a 9 is here, the 9 cannot be doubled because that already adds up to 18. If we have a 9 here, the rest of the digits add up to 7. And one of them at least has to be doubled. The minimum amount doubled is 1. So this has to be 1, 2, 3, and 9, with only 1 being doubled and 3 of them not being doubled. One of these two has to be doubled. So these are both non-doubled. So we have a blue and a green here. We don't know which. This cannot be 3 and 7. This has to be 4 and 6, which eliminates 4 here. The remaining digits in this box have to be 5, 7, and 8. So 5 cannot be here. This is 7 or 8. One of these is 7. We have a 7, 8, 9 triplet in row 4, which eliminates 7, 8, and 9 in the rest of the row. This can't be 7 or 8. This is 5. This can't be 8. This is 2. This has to be 7 or 8, but it cannot be 8 because of the 8 in the column. So this is 7, which makes this 8, which makes this a 7, 9 pair. So the 7 is in the non-doubled, and the 9 is doubled here. This digit is doubled, so it's consecutive with a non-double digit. Because this is even, this has to be odd, and the odds can never be double digit. So it could be 3, 5, 7, or 9 here. It can't be 5. It can't be 1, because 1 would have to be next to a 1 doubled, which is not allowed. This blue has to get out, so the blue has to go at least here. This is blue because of this 2x2 box having 3 greens in it. If this is 3, this could be, that's 3 in value next to 1 doubled or 2 doubled. Both of those work. 7 in value is next to 3 doubled or 4 doubled. 9 in value is next to 4 doubled or 5 doubled. But it cannot be 5 here because of the 5 in the column. We know 3 cannot be either of these, though. Where is the 3 in column 9? It must be one of these 3 cells. So these can't be 3. 3 has to be, this is 1, 2, 3, or 5. And 3 and 5 both have to be here. This cannot be 1 doubled because that's 2 in value. This cannot be 2 doubled because that would be 4 in value. It's not consecutive with 7 or 9. So this has to be 4. Which means this cannot be 4. Where's the 4 in row 1? It has to be here. So this is 4. One of these two is doubled. Well, we know it's the 1. So 1 cannot be here because 1 has to be the doubled value. Therefore, since this is 1, this can't be 1 here. So this is 2, this is 1. That eliminates 2 from being either of these cells. Remaining digits. Okay. We have a 2, 3, 7, 9 quadruplet in column 7, which eliminates 2, 3, 7, 9 in the rest of the column. Therefore, that leaves this as 1 and 8. This can't be 1. This is a 2, 3, 5 triplet. That eliminates 2, 3, and 5 in the rest of the box. So this must be 6, 7, or 9 here. This digit is doubled, and it's consecutive with another digit. So this must be an odd digit. So this is 3, 5, 7, 9. This could be consecutive with 1 through 5. Doubled. Okay. The remaining digits in row 4 have to be 1, 3, 4, and 6. Okay. Interesting. This cannot be 8 doubled in value. but that doesn't tell us very much. This cannot contain 7 and 9. To add up to 16, it would be 368 or 458. No, 458 doesn't. No, 268. 268 or 358. So that is possible. As non-doubled, essentially. Remaining digits in column 4 are 1 through 1, 5, 6, 7, 8, 9. Obviously, this cannot be 8 or 9 here, because these two digits add up to 8. This can't be 7. Can this ever be 1 doubled? I guess with like 9 doubled? Yeah, possibly. These have to be the same type. Okay, these three are green, so this must be blue because of this 2x2 region. That doesn't tell us anything really. Can this ever be 3 digits doubled? I don't think so, right? At least one of them has to be non-doubled. Because if 3 digits doubled here, it's either 125 or 134. If it's 125 doubled, all doubled, that eliminates 2, 6, and 3, 5, adding up to 8, which would then be doubled to 16. Same with if this is 134, that forces this to be a 6, which would force this to be 3, 5 doubled, but that doesn't work because we already have 134 here. So one of these at least must be undoubled. We don't know which. Where is the 8 in column 1? It has to be here. This can never be 1, because if this is 1, that would have to be consecutive with 2. Or I guess this could be 1 doubled, and this could be 3. Okay, so that's possible. These are also the same shading. No, that's not true. That is not true. You could have 1 and 4 here as the shaded parts. Okay. Okay. Either way that this goes, if one of these is shaded, one of these is unshaded. So it would be blocked here either way. So this must be shaded here, and it must connect out. So this is shaded here. So this is shaded. We don't know what this is, though. So this must be the digits 1 through 4. Oops. The digits, not the shadings. The digits 1 through 4, because if you have a 5 here, that 5 doubled would be add up to 10 by itself, and that's not allowed. Don't know anything about this. 7 can't be here. Where is the 7 in box 5? Can't be here because of the 7-9 pair. Can't be here because of the 7. So this has to be 7, and this can't be 7 here. So 7 must be one of these two digits, which means it must be 1 and 7 adding up to 8. And they have to be both unshaded. So these are both unshaded. That eliminates one. This 1, 7 pair eliminates 1 and 7 in the rest of the box. So this can't be 1. This can't be 1. We have a 3, 4, 6 triplet, which eliminates 3, 4, and 6 from the rest of the row. So this must be 1. This can no longer be 1. Therefore, where is the 1 in this box? It must be here. And the 1, again, must be doubled. So this is blue, which means this can't be blue. This is green. This has to be blue because this 2x2 area is all green otherwise. If this is green, it has to go out here. If this is blue, it still has to go out here because this would be green then, and this would block this. So this has to go blue either way. It can connect here though, so it doesn't have to be blue that way. So this is blue no matter what. At least one of these is unshaded. We're not sure if all of them are. The rest of these digits in box 4 are 2, 3, 4, 5, 6, and 8. Okay. So this adds up to 8. This adds up to 17. 8 plus 17, the rest of the digits add up to 20. Okay. Right, so this is 8, this is 17. That adds up to 25. So these 4 digits, without doubling, add up to 20. Can you ever have 8 outside? No. Because these, well, maybe? 1 and 7 are here. 1 and 7 are consecutive. 1 cannot be consecutive with 3. 1 would only have to be consecutive with 2. So this is 7, this is 1. The 7 is either consecutive with 6 non-doubled, or 3 doubled, or 4 doubled. So any of these work. These two are, they can no longer be 1 doubled with 4. That was the only one that really worked, with 1 being doubled and the other being undoubled. So these have to be the same shading. Since these are the same shading, they cannot be green. Therefore, these both must be blue. So these are both blue. Okay, so the other logical deduction you can get for yin-yang shading is if you have 2 of the same shading diagonally across from each other, the other 2 cannot be the other set diagonally across from each other. There has to be 1 that's the same shading and then 1 that's the different shading. Because if you had 2 green here, how does this blue connect to an orthogonally, right? It can't, because without cutting the green into 2 sections, right? So this blue trying to connect to here, how do you connect? It could have to connect something like that, and therefore this green would be 1 subsection, there would be another subsection here. So this cannot be green, therefore this has to be blue. This is in a 1-to-2 ratio. It cannot be 3 and 6. The only other pair that's in a 1-to-2 ratio with each other is 4 and 8. So this has to be 4 and 8, which means this can't be 4, this can't be 4. This is a 3-6 pair, which eliminates 3 and 6 in the rest of the row. So this is 4, this is 6. This 4-8 pair eliminates 4 and 8 in the rest of the box and the column. This can't be 4. This can't be 8. This can't be 6. This is a 5, 9 pair, which eliminates 5 and 9 in the rest of this row. So these can't be 5, and this cannot be 9. This therefore can't be 3 because these two digits must add up to 8 to double up to add up to 16. These are blue. Hmm. Okay, let's see. We have 1 doubled. It could be with 4 doubled. 2, 3 doubled with 2, 3 is possible. 1 doubled would be 2 with 8. 2 doubled would be 4 with 6. And 3 doubled would be 6 with 4. So these are the possible combinations here. One cannot be here. Can any of these be doubled? No. Because if any of these are doubled, that's at least 5 doubled, which is 10. And the other two minimum would be 6 and 7. Which would add up to 13 plus 10, which is 23, which is already greater than 19. So none of these can be doubled. Since none of these can be doubled, this has to be doubled here because of the 2 by 2 area. This adds up to 19 with 3 non-double digits. So I think it has to be 5, 6, and 8 with the remaining digits that we have. Right? Yeah, 5, 6, and 8. So this is 5, and this has to be a 6, 8 pair. This can't be 5, this is 9. This 6, 8 pair eliminates 6 and 8 in the rest of the column, so this is 9, which makes this 7, which makes this 8. This can't be 6 or 8 here. This is 7 doubled, so it's 14. That also eliminates 7 here. That means these two values sum to 11. 25 minus 14 is 11. But this could be doubled, so we don't know what these values are. Huh. Okay, these are all green, so this must be blue here. These are all blue, so this must be green here. These are all green, so this must be blue here. And again, like we said in the logical deduction we had, these cannot be 2 greens here because this is a deadly pattern here. So this must be blue. Connects that way. This then is doubled plus a single digit, and it cannot be 6, 7, 8, or 9. So this has to be 4 with 3 doubled here. That makes this 6, which makes that 3. The 6 eliminates 6 here, so it's 5 and 6. This is doubled. So we have 1, 2, and 5 here. The remaining digits in column 6 are 1, 2, and 9. This could be 5 doubled with 1. That adds up to 11. This is doubled, so this has to be an odd digit. So this is 5 and doubled with 1. Or it's 1 doubled with 9, adding up to 11. So either way, there has to be a 1 here. So 1 cannot be here. This is 2. 1 has to be here, which means this can't be 1. This is 8, which forces this to be 1. This can't be 1 either. This 2 eliminates 2 here. 8 cannot be here anymore. 4 has to be one of these 3 digits. This is 3, 4. This has to be 3 doubled. because 3 as a value is not consecutive with 7. Okay. What are these values? If this is 2, 6. What can be doubled and what cannot be doubled is kind of the question, really. Obviously, you can have 2, 6, 8, 3, 5, 8. Non-doubled. Oh, this could have been 4 and 1 doubled. Ooh. Well, we did know with the 7, 9 and the 7 that therefore this had to be a 1, 7 pair. But this was actually incorrect assumption. This could have been 1 doubled. But with the 7 having to be here, the 1 has to be here. So therefore that still works. Therefore that's 2, right? And we would have figured that out because we knew this had to be 7, 9 because 8 had to be here. 7 couldn't be here, here, or here. So this had to be 7 here, which made that a 1. And therefore that eliminates 1 from being a possibility there. Anyways, we haven't really used this at all. We did kind of use it for this, but we would have figured it out from the 1, 7 pair having to be here. So 1 couldn't be here, then it'd still have to be here. So that's still valid. We don't have to go back through there to resolve that for this area, this pair here. What else do we have? 7 is one of these two. That's fine. It's 8 in value. That's fine. If this is blue, this 2x2 area would have 3 blues, so this would have to be green, but you'd have that deadly pattern, so this cannot be blue. This is green. Since this is green, this has to be blue here. This cannot be 2 blues. And we know it's 2 and 4 then because of the 1 not possibly being there. So these have to be green. So these are both green. We don't know which one of these is 3 or which one is 7. So, this connects this way. So it does come down to this anyways. I don't know. So what can be doubled here? 8 cannot be doubled, obviously. Can 6 be... Okay, 6 can't even be here. So 6 can't be here, therefore this can't be 2. This is 3 or 6 here. 6 cannot be doubled because it would be with 2 and 4. 6 doubled would be 12 plus 2 and 4, it would be 18, and that doesn't add up to this cage. 5 cannot be doubled. Right, 5 can't be doubled because that would be with 3 and 4 at minimum. That's 7 plus 10, that's 17. 4 can be doubled. 4 doubled with 2 and 6 works, or 3 and 5. Ugh, that's not good. So 4 could be doubled, or you could have 3 non-doubled. If you have 3 non-doubled, this becomes doubled, right? Hmm. Ah, one of these has to be doubled because you cannot have at least one of these is doubled. I don't so because you can't have this 2x2 box be all undoubled. All green, in other words. So one of these is blue, which means it's doubled. Um, you can't have 2 doubled because that would be 2 and 4 at minimum. So that would be doubled, would be 2, 4. That would force this to be 3, 5. So you would have 6 left. 2, 4 doubled is 6 times 2, which is 12, plus 6 is 18. So that would not add up to 16. So only one of these is doubled. And therefore this is undoubled. So we have a blue and a green here. The double has to be 2, 3, or 4. Can it be 3 ever? 3 doubled would be 6. To add up to 16, you need a 10. And the only 10 possible would be 4 and 6, but the 3 and the 6 would eliminate all possibilities for this cell. So it cannot be 3 doubled. It's either 2 doubled or it's 4 doubled. We're not sure which. Either way, then... Actually, where is the 1 in column 3? Can't be here because of the 1 in the box. Can't be here because of this 1 here. This 1 can't be with any double digit, and 1 doubled. And 1 cannot be here because of the 1 in this row. So none of these could be 1, which means this is a 1 here. So this is 1, this is 2. This is 2 doubled, so that's 4 in value. That must be next to 8, which makes that next to 4. 4 cannot be here. Therefore, this must be the 2 or the 3 doubled. And we showed that they can't have the 3 doubled because that gets 6, and the other two digits must add up to 10. And without 1, 9, or 3, 7, it's either 2, 8, or 4, 6. But 4, 6, 3 being here makes this a 2, 6 pair to add up to 8 doubled, which adds up to 16. So therefore you can't have 2, 8, or 4, 6 here. So 3 cannot be doubled. This must be a 2 doubled, which means this can't be 2. This has to be 5 and 3, which eliminates 3 and 5 here. So this is 6, which eliminates 6 here. That leaves the rest of column 1 as 2, 4, and 8, which eliminates 2, 4, and 8 in the rest of the box. These can't be 4 anymore. So where is the 4? It can only be here. So this is 4, which means 4 cannot be here. Where is the 2 in row 9? Can't be here because of the 2, 8 pair in the box. Can't be here because of the way the cage adds up. So this must be 2 here. This 2, one of these being 2 means this can't be 2. This is 8, this is 2. This 8 forces this to be 6 and 8. This is 2, so this cannot be 2 and 5 here. This is 2 doubled, so it's 4 in value. And it must be... So 16 minus 4 in value is 12. So these two must add up to 12. It's 4 and 8. So this has to be 4, and this must be a 2, 8 pair. That makes this a 6. This 4 eliminates 4 here, so this is 8, which makes this 4. 8 eliminates 8 here, so that's 2, and this is 8. The 2 has to be doubled, so this is the blue. This is not blue. Again, we can't have... this blue has to go out somewhere, so this has to be blue, which makes this green. This green has to go out somewhere, so it has to go out here, and then here. So this cannot be 2 here. This can't be 3, it's 5, which makes this 3. If this were 3 doubled, it would have to be with 5 and it could be 7 in value. This can't ever be 3 anymore anyways. So this is 5, 7, or 9. Could be 6 or 10 in value. We have a 3, 5, 7, 9 quadruplet in column 3, which eliminates 3, 5, 7, 9 in the column, so this must be 6. This can't be 6 anymore. We have a 7, 9 pair in box 9, which eliminates 7 and 9 the rest of the box. This can't be 9. This is 6. Again, this has to be... So this is being doubled, and it has to be 9. So this has to be non-doubled 7 to add up to 25, right? 18 plus 7 is 25, but if you had 9 single and 7 double, that would be 14 plus 9, which is 23. So this is 9, which means this cannot be 9. We have a 3, 5, 3, 5 pair in column 3, which eliminates 3 and 5 in the rest of the column. So this is 7, which makes this 9. That makes this a 2, which makes that 5. This 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 9, and this is 1. This 9 eliminates 9 here, so it's 7. That eliminates 3, 7 here, so this is 3, this is 7. This 3 eliminates 3 here, so it's 9. This 3 eliminates 3 here, so it's 2. This has to be 3. The 3 was a doubled value here, so this has to be blue, which means this can't be blue. This is green. And, ooh. No, this can't be green. This has to be blue to connect this. I don't know why. Yeah, this was already connected this way, so it didn't have to go that way. And this blue then doesn't connect otherwise if we make that green. So that's why this is blue. And this is the shading. So we just need to finish out by just normal Sudoku. This digit is a 9. This cannot be, this has to be a 1. This has to be 3 or 5. Ooh. 5 doubled is 10. And 10 is not consecutive with 7. So this must be 3 doubled, which makes this 5, which makes this 3, and this is 5. Yippee! Yes, yippee. Apologies. I made a couple of actually pretty bad mistakes here. One was this assumption that this had to be... this still had to be a 4 no matter what, because it was 4 with some doubling, or one... Sorry, with the same doubling, or which would make this 2 or 8. This could never be 6, because if it's 6, it can only be with 3 non-doubled, or 6 doubled, which would be itself, which is not possible. So this had to be a 4 of the values possible. And this, I should have made this, could have been 2, 8, or 1 doubled. That was the possibility. And that was a mistake there. But this 7 solved that. And then I don't know why I shaded this I made this unshaded when it should be, when this had to connect out. So those were some pretty egregious errors there. But I hope you enjoyed the solve otherwise, and I'll see you next time on Frank Puzzles. Take care.